Okay, we're here to do a little review of the final. I think it's necessary. I'm going to go through with this video and just go through the questions, look at them one by one, and then just discuss the answers. Okay, this is going to be helpful for review or finding out what went wrong. So let's just get to it. Let's look at question number one. Okay. Question number one got a few people. The problem with this question was that we have an x value which is updating. We get an input, x. We then have an equation, x equals x plus x. So how does the Java language do this? Well, it adds up x plus x. So essentially we have two x's now. We save that result into x. Now x has been updated with two x's. Then we do another equation. Now this x is not worth the original x over here. It's worth the x over here, which was 2x. Now we have 2x plus 2x. How many x's? 4 x's. Then we do another equation here. We've updated the x here to now be worth 4 x's of the original x's. Now we have this x over here, which is taking from here, 4x plus 4x saved into x. Now we have 8x, or 8 of the original x's. Okay, so as we're going, we're updating the value of x. You can't just ignore that. You have to use it in your equation. So that's why the correct answer is 8 times x here. Java, I mean, you're updating a variable. It's not the same as the original one. It's being updated. Okay, next. Let's look at this class. Class student. Okay, we have a name and an age. We don't show the student. These are both constructors. You can tell because it's the same name. So these are two constructors. One takes no inputs. One takes a string and an int as your input. Which of the following will compile without error? Student A equals new student. This one's fine. It's going to use this constructor here. Public student. Well, this one. This one is going to use string and int. That works. That's fine. So these two are okay. String, int. String, int. This one is string and string. You see this is a quote here. That's a string. So string, string will not work. There's no constructor that takes string, string. We only have nothing or string int. So 1 and 2 will work. 1 and 2 only. 3 does not work. Okay, consider the following class definition. Public class bird. All right, it has 3 variables here. They're all private. 2 strings and a Boolean. When we have a constructor, right, to build this object, we need to have a string, string, and a Boolean to make this thing. So we can add more constructors because Java allows you to add more constructors. You're okay to add more, but you can't add a constructor with the same signature, i.e. you can't add another string, string, Boolean constructor. You can add a nothing constructor, that's fine. You can add just one Boolean or whatever. Just don't add the same signature here. We've already got that one, string, string, Boolean. If you add another one of the same, you're going to get confused. Which one do you use? Right? It has to be a different one. So string, string, Boolean. This one is, where we got string, string, Boolean. Wrong. Can't add that one, okay? That'll cause an error. It's the same signature. Next. Consider the following method, public int pick Boolean test. Okay, I'm going to go to the paper for this one. All right, in this example, we have this method, which is being used in here, and the result is going to become the input for this one. All right, so let's take a look. Public int pick, the return value, so the return result is an integer. It returns an integer. Its input is a Boolean and 2 integers. If the Boolean is true, it will return X. If not, return Y. Pretty simple method. But where it gets tricky is we've got it inside here. Okay, so let's write it down on the paper. We have pick false, pick true 0, 1, pick true 6, 7, and another parentheses there. Okay, so the first thing it's going to do, Java is going to start to evaluate the inside parts here. It's going to do this. It's going to find the result here. And then it's going to find the result here. So let's run this method using these inputs. Okay, so public int pick with true and 6 and 7. Well, we know that looking at the code, if test is true, returns the X value. So this one is going to return the 6. This one also is true. It's going to return the X value, right? This is the X, this is the Y, this is the X, this is the Y. So it's going to return the 0. Finally, let's simplify, write this again. I mean, substitution. So basically we end up with pick, right? False. And this becomes 0 and 6. Right, that comes there. This result comes there. Now, when pick is false, it returns the Y value, right? Which is 6 in this case. So, final result, 6. That would be D. Next question. Consider the following class. Sum class. Private int num. Sum class. Okay, so we have a constructor. We have one instance variable here, an integer. And when we get a constructor, when with one input, we take that, save it into the variable. Increment will add a number to our num. It'll take the value and then add more to it. And getNum will just give you back the number that's here. Okay, so we're trying to figure out what's printed. We know that increment will add 200 to whatever the value is. We know that a 100 here will save that into this part of the variable, into the instance variable. So we have a sum class 1 equals new sum class. Sum class 2 equals new sum class. So at the moment we have two different classes, we have two different objects, 1 and 2. They're both from the same class, but they have their own data. Sum class 3 equals 1, meaning that 3 is not building a new sum class. It's actually just copying and pointing to this, right? So it's pointing to 1. So it's essentially the same thing as 1. It's just pointing there. Now, so when we change 1, it's going to change 3. Because 3, if you look here, we have one sum class, 1 is a new sum class, right? Which basically makes a new object in the memory space, right? Some new object, sum class object. And then sum class 2 also makes a new sum class, right? So we got a new box here, right? Also with 100, has 100 in it, right? 100 in it. Sum class 3 is just saying, you know what? I'm not going to make a new one. I'm just going to point to this one. This one. It's pointing to this object. So therefore, when we change this one, obviously 3 is just going to follow whatever this is. It's pointing right to here. So therefore, 1 1 dot increment 200. We'll add 200 to this object's number, which is 100. So it essentially makes it the num variable will now equal 300 in there. Okay, so therefore 3 is also going to be pointing to this one, right? It's the same object. It's not a new object. So when we print 1 get num plus space 2 get num space plus 3 get num, we end up with 1 get num, which is 300 now, plus space, right, so we got a space in there, plus 2 get num, which is still 100, and a space, and then 3 get num, which is the same as 100, right? So 300, 100, 300 is the answer. And so that would be C. Next question. Okay, so we've got a public static void message, int A, int B, and C. This is a method which takes 3 inputs. 3 inputs here, all integers. This is asking us to figure out what's happening in this nested logic, okay? So it's giving us an example here of 5, 15, and 5, okay? So in this case, A is 5, B is 15, C is 5. So if A is less than 10, is it true or false? Yes, true. So we will be running this part of the code. But notice that we also have an if here. It's not an else if. So this could also be true. It's possible. So let's just start with this one. Okay, so if A less than 10, if B less than 15, well, that's not true. Sorry, B less than 10. This is not true. So that won't run, but it will print this, system out print Y. So far we have a Y printed out as a result. And then we go here. If C is less than 10, true, yeah, because C is 5. So C is less than 10, we will be running all of this. Okay, let's check in here. If B is greater than 10, true, B is 15, so B is greater than 10, we will also print out Y. So Y is also printed. Else will not run because we found this to be true. And there we go. So D, YY. All right, next one. Class definitions, public class person, name, and this is a method just to return this name. So this is the variable, this is the method. We have a book, author, title, borrower. Now, borrower here, I mean author, title, they just take these inputs, right? Borrower is a person, right? So a person is an object. We've already declared that a person is this. So person is an object. When an object is nothing, it's null. Basically pointing to nothing. Nothing in Java means nothing. I mean null. Null is just saying nothing. It's nothing yet. We can't say empty string because it's not a string. It's an object. So an object is basically pointing to nothing, right? So right now borrower, I can erase this one. All right, which is essentially we know this is nothing, right? And something happens here in print details. We print system out print author, title. If missing condition, then we're going to print the borrower. Okay, so this is checking to see, is there anything that it prints? Can we print something? We can't print if it's nothing. This won't work. This will give us an error. If we try and, if the object is pointing to nothing and the object is nothing, then we can't run any method like this because it won't work. So we'll need to do a test here to see if it's really nothing or not. This equals method is not useful for us right now because equals borrower maybe is nothing, right? So borrower, we can't run any method from borrower because we don't know if it's anything. It may be nothing, right? It may be null. If it's null, it has no methods, no variables. There is no object there. It's a pointer to nothing. So there's nothing there, right? Normally, an object is create an object, and then you point this variable to that object, right? Then it's something. But if you're pointing it to null, it's nothing. It's a black hole. You can't run anything from there. You can't access any methods, any variables. So this is what we're saying is, if you try and run equals, dot equals is a part of an object. It has a method called equals, which will do something. That's a method. But null fields don't have, null is nothing. So one won't work, basically. Two might work because we can check, is borrower null? Is borrower the same as null? And that would work. And here, borrower.getName, no, doesn't work, okay? So the only thing that would work is 2. Because these are both methods that may possibly be null. We don't know. Okay, number 8. In number 8, we have a Boolean expression, x and y, and not x or y. So here we need to work out what we've got, what we're dealing with, okay? What's the result of evaluating the expression? Can we possibly simplify this to be more clear? All right, so one of the laws of transmutation of like Boolean algebra, the De Morgan's laws, is that we can simplify algebra. So x and y and not x or y, like this. We know that this one we can simplify because we can flip the inside and do the outside. So we can do, instead of this, we can multiply it in and flip the inside. So we can go not x and not y, like that. So what's the problem with this? Well, the problem with this is that we have no. The problem with this question is that we have x and y and not x and not y. So these are kind of the opposite things of each other. This, if let's say x is true, okay, so let's just, if you're really confused about that this is true or not, we go x, let's say x is true, y is true. Draw a truth table, like I say. You do x is true, y is true. X is false, y is false. X is true, y is false. X is false, y is true. Let's evaluate what the result is. If they're both true, we have true and true. This is true. Hi, Cedar. I'm busy. Please close the door, Asita. I'm a little busy. Thank you. So if true and true is here, true and true, this will be true. And not true, which is false, and not false. Either way, as long as it's false here, it's false, right? So false. Now this false made this false, so the whole thing is false. Similarly, let's try it again with the false false. If you're not convinced yet, false here, right? And not false and not false. Well, we've already got a false and an and, so the whole thing's going to be false. Again, Let's make a true and false. Well, true and false makes it a false. This makes it a false, so it's false. And false here. So everything's going to end up false. And that's why we get false always. All right, next one. So let's do the multiplication again. So we have not, comma, not, A not equals to B, and B greater than 7. All right, so let's firstly take this exclamation mark and move it in. I think I'm missing a, I'm missing a bracket there. Okay, so let's move this in, right? So move that exclamation mark in. So we switch it, not A not equal to B, or not B greater than 7. So now it's moved into the side, and we flip the result, right? Then we can eliminate that, because there's not is just eliminated. So now we have a situation where we can put this one inside here. So to do that one, we can get rid of that and switch it to B less than or equal to 7, right? Flipping that result. Still or here. So we have A not equal to B, or B less than or equal to 7. And that would be our B. Okay, so that's just the Morgan's laws in action. All right, let's look at question 10. Question 10 is, if num greater than 0, if num modulus 2 equals 0, basically if the number is even, print A, else print B. When you see this, you should recognize it as being if the number is even. Modulus 2 is always about being even. So here we go. We have if num greater than 0, we're going to do this. If basically, let's describe this. So if num is a positive, then and it's even, it will print A. If it's odd, it will print B. So let's see. When num is a positive even integer, A is printed, otherwise B is printed. But what happens if it's negative? If num is 0 or negative? So let's see if there's a better answer. Num is a positive even integer. A is printed. When num is a positive odd integer, B is printed. Otherwise, nothing is printed. So I think that would be a better answer here. Okay, next question. Polyvoid test takes an int x integer as the input. We have a variable here called y. Here we have that same formula again, x mod 2, so I mean even numbers. Y will equal to 3. So if x is even, y will equal 3. If x is greater than 9, y will equal to 5. Else, y will equal to 1. Print y equals y, right? So it's just going to print out the result here. So therefore, which of the following data sets would test each possible output? So we want one of this, and one of this, right? So one where it's even number, one where it's greater than 9, and another case where it's not even and not greater than 9. So even, greater than 9, not greater than 9, right? Not even, not greater than 9. So that would work. Note it would do this in order, so it would take the even one first. If it was even, yep. So I think that would be the results. I think that would work. Let's look at this one. Would this work as well? And this wouldn't work because, oh no, this wouldn't work because this would catch even on the 12. So even would get caught here and it wouldn't run. So that one, yeah, it wouldn't work. So we have, maybe we need an odd number and it has to be not even and greater than 9. 8, 9 is not greater than 9. So that would run this one. And this one would be greater than 9 and it would run this part. So that would work. Okay. All right. This method is, let's say, biggest. It returns an integer as the output. It has 3 inputs, A, B, C. There's an error here. So let's see what the error is. This is meant to return the greatest of the 3 integers. If A is bigger than C and A is greater than C, A is greater than B and A is greater than C, we return A. Seems good so far. If B is greater than A and B is greater than C, return B, else return C. What is the problem? Well, is there a case where they're somehow equal? What's going to happen if one of them is equal to the other one? So let's say B is greater than A, and no, let's say B is equal to A. No, that wouldn't work. I think, let's see, B is greater than A. A is equal to B. If they're equal, I think it won't matter because it will still print out which is bigger. And if they're equal value, then it will be fine. However, it's saying and here. So let's say A is the biggest one. A is biggest. And so A is bigger than B, yes. But B and C are the same. A is greater than C. That would return A. That would work. Okay, so I'm going to turn to the A and B have equal values. It may not work when A and B have equal values. If A and B have equal values, then it may return C instead, because A equal to B This one was a tricky one. It's a little bit hard to gauge, but we're missing the equal part. I think if A is equal to B, it may not return A as the result because A is not greater than B. Now, and B is not greater than A. So therefore, if A is not greater than B, B is not greater than A, these will both be false. Even though A or B might be the same, right? And they may be the biggest one. It will end up returning C as a result. So it wouldn't work if they're even. It'll go to the default value. All right, number check. So here we have number check, and we need to look at this as we have 3 ints, type A, type B, type C, and we have a for loop. For loop will run up to the max number here, starting at 1, less than equal to max number, so it'll do that many iterations, and it will increase by 1 each time. If k is even and k is divisible by 5, then type A will be plus plus. If k is just even, type B will be plus plus. And if k is divisible by 5, type C will be plus plus. So you can see this is quite a rare case when it's even and divisible by 5. This is going to happen every second time. This is going to happen every 5 times. And so if we call number check 50, we have to say what will we get? Type A, type B, type C. What will be the result? Well, we know that this one's going to run once every 10 times, possibly, because 5 and 2 meet up. We have an even number. A multiple of 5 is every second time, right? So we have 10, 20. So 10, 20, up to max number 50. So 10, 20, 30, 40, 50, right? So that's 5 times. It's going to run this one. It's going to run this one every second time, so it's 25. And it's going to run this one every 5th time, which is every 10 times. So 5, 25, 10 would work for this one. That would be the answer here. And pretty sure that's the right answer. Okay. Great. Okay, 14. I'm going to do this and I'm going to do a part 2 a bit later. The following code segment, we have int value equals 15, while value is less than 28, system print value, value plus plus. So we are going to start at 15 and keep going until value, or while value is less than 28. So as value keeps increasing, it's going to cut off when value gets above 28 or 28 and above. So the first number that we print out is going to be 15 because we're printing directly 15 here and value go there, add the value after. So we print, then add, print, add. The final value will be printing the final thing before this fails, which will be 27. Prints it, it increases it, and then the while stops. So 15 and 27. That's quite a straightforward question, that one. Not a big deal. Okay. Okay, we'll just... Okay, for this last one, we're going to do public in mystery. Mystery is a method where we have a loop, a while loop, and it continues while x is greater than 0. Now, remembering x is an int, so x is an int. When you do a division, such as when we have our 1034 is the number we're looking at, this number is an int. So if you divide this by 10, and you get 103.4, it ignores the 0.4. It saves the int. Okay, so it's 103. So let's look at the equation. While x is greater than 0, if x divided by 10, modulus 2. So x divided by 10 is this. Modulus 2 equals 0. Well, x divided by 10 is 1034 divided by 10 gives us 103. Modulus 2 does not give us 0. So therefore, we're going to go and divide x, which, remember, x is still this. Now we're going to update x to be divided by 10 version. So we update it to 103. So now x is 103. Do the loop again. Now 103 comes through. 103. If x divided by 10, right? So divided by, sorry. If x, which is x here now, x is 103. If x divided by 10 modulus 2 equals 0. So this becomes 10.3, which we ignored that. So it becomes this. Modulus 2 is 0, yes. Then we return x. So we still have x as this value. So 103 will get returned. So therefore, our answer is 103. Okay.